name is Vlad Galibov, and I'm the head of Omdia's Cloud and Data Center Research Practice. I am joined today by Lynn Comp, who serves as Corporate Vice President for Server Products and Technology Marketing at AMD. As a seasoned data center networking and cloud computing leader, Lynn has more than 20 years of experience in software, hardware, IT infrastructure strategy, and product planning. Thank you so much for joining us today, Lynn.
Thank you so much, Vlad. I'm very excited to be speaking with you and your entire audience for your research practice.
Thank you. So, Lynn, the topic of sustainability was central to our agenda at Omdia's Analyst Summit in Austin this year, where we welcomed AMD on stage to give us your perspective. And in the days to follow at Data Center World, I saw that many data center operators, and actually the ecosystem at large as well, can still benefit from a conversation around actionable practices to improve sustainability. So, in your opinion, why is sustainability important?
So from the AMD perspective, sustainability is important for a number of reasons. One of them is that as the dependence on data centers grows worldwide for so many different industries and individuals, it's really important to have thought in advance. How do I minimize the footprint and the impact on the communities in which our data centers happen to be housed, because they're getting very, very large. Some of the citations that I've seen is that some data centers are on average 100,000 square feet. So that's a huge, huge space that needs power and cooling. And so the question is really both, how do I give more to my customer base who want to add new services and new capabilities to make it easier and remove friction from the purchasing cycle, while at the same time, I'm minimizing my footprint. So it's not just a matter of raising my performance, it's how do I do that while I am lowering any negative impact that I could possibly have on the communities that are depending on this technology.
So why does it matter for digital infrastructure and data centers to be sustainable?
They're growing, first of all, and they have a huge demand on electricity and power. The other thing that's really fascinating is when you look at some of the news leaders that we've seen recently, workloads are growing by 20%. And we didn't have 2 years of capacity build out, because most people were sheltering in place. And so you have too little footprint, a lot of demand that didn't go away. It just grew. It didn't go back to normal from pre-pandemic levels. And so a lot of the companies are looking at, how do I do less with more? And that was before AI. When you look at the demands that the application of AI is requiring, the performance requirements are doubling every 3 to 4 months. And then when you look at the memory requirements, like how much memory, these large language models require large memory spaces, and you're seeing this 20x year on year growth, that's a lot of space. So it's not even a matter of sustainability and zero impact. We've moved into I have to add all these new capabilities and workloads for my internal and external customers. I don't have room to do that because it's not easy to get capacity, because it's been at such a short supply. So I think that that's another reason why it's really hitting digital infrastructure harder and faster than what was anticipated.
You know, it's so interesting that you would talk about space, that you would talk about efficiency and how you utilize space in the best way. Because when we hear people talk about sustainability, the conversation, quite frankly, tends to be centered around renewable energy.
Yeah.
The central reason why we asked AMD to provide a perspective at Omdia's Analyst Summit is because we share a vision that sustainable strategy should be much broader than renewable energy. Where do you see the market growing in terms of energy efficient hardware, cooling, and also in terms of the industry standards that relate to sustainability?
You know, it's so fascinating you asked that, Vlad, because I've been asking, where are the efficiency metrics and benchmarks for even compute infrastructure. It's hard to do it for data center wide when almost half of the power is being used for cooling. So it's not even being used to power the computing itself. And, it's a really interesting space in terms of lack of standards, because people are really struggling to figure out, how do I measure it? One of the things that I was encouraged by is Spec Power is starting to really give a flavor for how much work can I get done for every watt that I spend. I have found that there are enterprise leaders that are global in their footprint. Their current number one metric is watts per VM. And so it's really, how much does each service instance cost me in power is the number one criteria. And I think one of the things that a lot of people are missing is it's very similar principles with renewables. Reclaim and reuse are two critical components. So when you're talking about a data center that has 4 or 5 year old infrastructure deployed in it, and it's Xeon Skylake generation, so it's 4.5 to 5 years old, would you have a guess as to what you think updating that to modern infrastructure would do in terms of power and space?
I have actually seen an example, because you showed it on the Analyst Summit, and you can halve your footprint or potentially even better. It was
even better.
Images. Yeah. It was just staggering images of, a row of racks being replaced by, a couple.
Exactly. We've done an actual calculation where you have 73% fewer servers to move to 4th generation EPYC and 65% less power. So if you think about it from the perspective of, how do I lower my footprint? If that's your goal, really updating and consolidating your infrastructure, because the latest process nodes are so much more energy efficient. You also have better security, not just because you have AMD Infinity Guard, but also think about all of the security updates in the last 5 years that have had to be applied. So there's really only goodness in doing that. And then you have options, right? You can either reduce your footprint, or you can save space to put in new workloads. And you don't necessarily have to go put in new power and new cooling and disrupt the power grid for the locals. You have the ability within your own power to basically get 3/4 of what you had back. So I think that it's thinking about it in that regard of a very aggressive reclamation project of data center space and power that allows so many more options for the operators. And then when you're choosing what to modernize on, really not falling for the TDP or just performance per watt, because you can get great performance per watt characteristics by just juicing your performance. I think it's really, how much work do you get done for every watt you spend? And have people have those two mindset shifts, it will have a huge impact on the efficiency and sustainability of their data centers.
In the context of what you've just highlighted, the counter argument that I hear from people is that, well, actually, if we keep our servers longer, we're lowering our Scope 3 emissions because they don't get produced. But if you optimize your footprint, you don't have to build a new data center. Right. And that in itself has huge Scope 3 emissions.
Exactly. And, we've actually looked at the break even, and in the first year, what you would spend for completely new AMD gear, it basically is paid for. And then you've got another 3 to 5 years life cycle where your operational gains, and this is without being able to free up admins to go do DevOps and create new applications and services. Without that, you're starting to gain millions of dollars each year in savings that can be applied to something else. So it's a bottom line budget positive, even counting the net new cost of all of the hardware. And then because you're able to do more with less, you have the ability. I've had some data center owners tell me, I need to shift more of my IT staff to doing software development. Well, this would allow you to do that so that you would have 5 more developers, which are much easier to get in-house than try and hire in the market today.
Yeah, that's true. And so can I, for a second, bring us back to something you mentioned? So obviously, you and I don't exist in a vacuum. The elephant in the room is the AI kind of revolution. I mean, AI is not new. My uncle always likes to tell me that in the 80s he was doing AI, but I think what's happening now is we really are seeing it go mainstream. The problem is that with the most compute-intensive workloads growing the fastest, companies need some help. So how should companies plan to address this increasing demand for computing power while minimizing the rise of energy consumption or carbon emissions?
I think that what it really comes down to starting with is understanding where is my data and where does it need to be? And then to what extent does it need to be protected? Because once you have that question answered, then you can start coming up with multi-cloud or hybrid cloud strategies where you build what you need on site, which quite frankly is very often more efficient and more cost effective, depending on the maturity of the workload. And then you don't have data movement issues or data privacy issues. However, if speed and being able to ramp and burst assets out to get an answer done quickly, the fastest thing that you could use would be going to the cloud. And so it's this balance of the data traffic, the amount of data, the security of the data in terms of, am I even allowed to use the cloud for that? Because some data you're not. Relative to how quickly do I need to actually build this out? And I think that there's very, very clever DevOps and high-level language methodologies that if you design in advance, you can move things off and on-prem very, very smoothly and seamlessly. So you can balance it out in a very effective, efficient manner between on and off-prem, and being able to get the best of really fast time to burst relative to, I really need to protect this, or I have a lot of data and I just can't move it.
So Lynn, how is AMD addressing our insatiable demand for computing, and how do you see performance requirements changing in the enterprise over the next few years?
So first of all, AMD has taken the subject of sustainability so seriously. We made a very public commitment that we were going to improve sustainability across our part of the industry for HPC and AI training by 30x, and that is within a window of 2025. So that's a big commitment. And the good news is, as we've been basically grading ourselves, we're a bit ahead of those goals. So that's step one, and that includes everything from our own energy workload per watt assessment of how can we deliver more to the enterprises, that for them, higher performance is the difference between being able to run 2 product simulations in a day versus 1 or a half of a product simulation in a 24-hour period. So it's really material speed up that our customers see for more performance. But this 30x goal is really critical for us to be able to give that to them without them having to put in new power plants. I think the other aspect is the chiplet architecture really does allow us some flexibility. What we announced June 13th related to the Instinct as well as the APUs is truly much more of a workload-centric optimization. We'll be announcing some more workload-centric optimized products coming out later this year, where you can really see a tightening of the focus on the requirements for a very specific space. And we have the ability to do that in a very, very efficient, time-wise manner because of the chiplet architecture, giving us some incredible flexibility.
And I think your kind of expanded portfolio actually enables then your average enterprise that does not have a huge engineering team, that's not going to, hire ASIC designers or, software optimizers to optimize their infrastructure to their workload. And actually also it works out of the box because these are kind of tested, right? They're enterprise grade. And then as a result, an enterprise can end up having something that resembles what you would see in Meta's data centers or Microsoft or Google or Amazon. And I think that's really powerful.
Yeah, absolutely. Because there's such a delicate balance between over engineering workload optimized and losing flexibility. And accelerators don't come for free. You basically fork your code base, which means you need more developers, you need more management. You have to really be cautious in your validation of your software. And so the chiplet approach and the APU approach really helps keep it as general with clean cores and clean architecture. So you're not paying for accelerators in a storage space when what you really need is an accelerator for security capabilities. You need to be able to have a little bit more refined choice. You don't want to have to pay extra logic that you're never going to use to go ahead and get that. And the chiplet architecture really does give a lot more flexibility there.
Absolutely fascinating. So thank you so much for your time today. This has been great. And I hope that people do continue the conversation with you guys because it's a very fascinating one and it's very necessary.
Excellent. Thank you so much, Vlad.
Thank you.